In this module of Chapter 10, Module 10.7, I describe a simple demographic model concerned with the control of African elephant populations through culling. The basic age or stage harvesting model presented for spider mites assumes that the populations consist of subpopulations that can be harvested independently and in their entirety. Next, we consider here harvesting as it applies to culling in social groups, such as in elephants, where the best practice in elephant management is to remove the entire family or subherds because selective killing disrupts the social organization of the subpopulation. Kruger National Park is a game preserve in northeastern South Africa that covers an area of nearly 20,000 square kilometers, and where all of the big five species reside, including the African elephant. In some regions of Africa, the elephant populations are in decline due to habitat destruction and poaching, but in Kruger, their populations are expanding to sizes far beyond the carrying capacity of the park. As a consequence, African elephants in Kruger have the potential to completely alter their surroundings and act as the predominant ecosystem engineer in protected areas. Given that an adult elephant can consume 180 kilograms of vegetation per day and can uproot trees for access to a few choice leaves, elephants have the potential to convert habitats from dense woodlands to sparse shrub, which can have far-reaching ramifications for other plants and animals residing in these parks. Because of these potentially destructive pressures, an elephant culling program with selective slaughter was implemented in 1967. But due to public outcry, park managers discontinued this program in 1994, and as a result, the elephant population had increased to over 15,000 individuals by 2006. Three options exist for managing elephant populations. The first is contraception, which involves either immunocontraception, that is, elephant pill, or sterilization. One problem with the contraceptive option is a population modeling revealed that an effective program would require the treatment of several thousand cows annually at a cost greater than the entire annual management budget for South Africa national parks. Another problem with this approach is that contraceptive implants create disturbing post-treatment effects and behavioral aberrancy in elephants. Additionally, sterilization by this method is not reversible, and reversing contraception may be important if, at another time, populations are in decline due to a disease epidemic or heavy poaching. The second option for managing elephant populations is relocation. There are at least three problems with relocation. First, moving adult elephants is stressful to the animals, extremely costly and logistically challenging due to their large size. Second, translocation of juvenile animals is considered inhumane because it removes them from their family unit. And third, opportunities for translocations are extremely limited as there is little space left into which elephants can be moved. The third option for control is population harvesting through culling or selective slaughter. Because sociality in elephants is highly developed, removal of any one individual is disruptive at the family and the subherd and herd levels. If the removed individual is a matriarch or even one of the senior subordinate breeding cows, the effect on the group can be devastating because the removal would constitute a loss of leadership, knowledge, and wisdom. Culling as a management actuarial strategy. Hypothetically, to reduce the size of a population with an initial population of 15,000 elephants by half would require culling elephants of all ages for 10 years. The annual rate lambda at which the population must decline in order to reduce the population of 15,000 by one half to 7,500 in 10 years is computed as the following. This equals the 10th root of 0.5 or 0.933. In other words, by reducing the elephant population growth rate to below replacement rate of 0.933, that is 6.7% less than replacement each year for 10 years, the population will fall to half the level of its current 15,000 individuals. The culling program can be considered as consisting of two phases, the first of which is the actual culling by 7.6% per year as shown here. Note that the number of elephants culled becomes progressively smaller through this phase because the fraction to be culled is applied to an ever-shrinking population. The number killed the first year in phase 1 is over 2,000 animals, and by the last year of this first phase, it is almost half that number, which is around 1,100. The second phase is maintenance. The 7% annual growth rate requires culling half as many elephants, that is 525 individuals each year, as was required by the last year of phase 1. This is still a large number of animals to kill and dispose of, but only a quarter of what was required at the start of the program. Note the stage structure of 52 infants, 185 juveniles, and 288 adults that need to be removed. Needless to say, killing of any elephants, but particularly killing infants, juveniles, and healthy adults, becomes a public relations challenge for policymakers and conservation managers. This ends Module 10.7 of Chapter 10.